Let's just dive right in with a massive question. Is quantum mechanics, the most successful, precise, and celebrated theory in the history of all science, just plain wrong?
Now you might be wondering who would even suggest such a thing. Well, this isn't some fringe idea. That quote, it comes from Gerard 't Hooft, a Nobel Prize-winning physicist. And believe me, he is not alone. Some of the greatest minds in the field, the actual architects of our modern universe, are starting to raise the alarm. So, what on earth is going on?
And right there, that's the heart of the dilemma. It's a huge paradox. On one hand, quantum mechanics works perfectly. But on the other, it might be leading us straight down a dead-end road. To really get why, we first have to appreciate just how unbelievably successful this theory has been.
All right, so for over 100 years, quantum mechanics has been the absolute bedrock of modern physics. And for a very, very good reason. Its track record is, well, it's just astounding.
Think about this number, 10 billion. Some predictions made by quantum theory have been tested and proven to be accurate to 1 part in 10 billion. What does that even mean? To put it in perspective, that's like me predicting the exact distance from New York City to Los Angeles and being off by less than the width of a single human hair. The math is just that good. It's almost unbelievably good.
And this success, it happened so fast. In the early 20th century, it was like a firestorm of breakthroughs. You had Max Planck kicking things off, suggesting energy comes in these little packets called quanta. Then Einstein takes that idea and solves a real-world puzzle with it. Then Louis de Broglie just flips reality on its head, suggesting particles can also be waves. And then boom, Schrödinger gives us the master equation, the engine that drives the whole thing. And just 2 years later, Paul Dirac's version of that equation predicted antimatter before anyone had ever even seen it. It was just one victory after another. A true golden age.
But, and this is a huge but, here's the twist. For all its incredible success, there are these deep philosophical cracks in the theory from the very beginning. Problems so weird that even the guys who invented it couldn't really stomach them.
Okay, so at the very core of all this weirdness is a principle called superposition. In simple terms, the theory says that a single particle, like an electron, isn't in one specific spot. No. Instead, it exists in this weird haze of all possible spots at the exact same time. It's a concept that just completely shatters our everyday logic. And this famous example just illustrates the divide perfectly. In our world, things are definite. A cat in a box is either alive or it's dead. Simple. But in the quantum world, the theory says until you open that box and look, the cat is somehow, magically, both alive and dead at the same time. This wasn't just bizarre to you and me, it was deeply disturbing to the very people who came up with the idea.
This idea was so unsettling that Erwin Schrödinger himself, the man who wrote the fundamental equation of the whole theory, said this. He was so disturbed by what his own math implied, things like particles just instantly jumping from one place to another, that he basically said he wished he'd never had anything to do with it.
And he wasn't the only one. Albert Einstein famously hated the idea of entanglement, where two particles can be linked across the universe and instantly affect each other. He called it spooky action at a distance. He argued the theory couldn't be the final story. It had to be incomplete. Now, for decades, physicists kind of just swept these complaints under the rug. Why argue with success, right? The math just kept working. But now we've hit a wall, a big one.
And this wall, this is the single biggest problem in physics today. We have two absolutely perfect theories that describe our universe, and they completely fundamentally contradict each other.
Think of it like this. It's like nature gave us 2 instruction manuals. One manual is quantum mechanics, and it tells us how all the tiny things work. Atoms, particles, all that stuff. The other manual is general relativity, and it tells us how all the big things work. Planets, galaxies. Both manuals are flawless in their own arenas, but their core rules are totally incompatible.
And when you put them side by side like this, the conflict is just crystal clear. Quantum mechanics is all about things being discrete, chopped up into indivisible little chunks. But relativity is built on the idea of a smooth, continuous fabric of spacetime. In quantum physics, time is just this absolute clock ticking away in the background. In relativity, time is flexible. It's part of spacetime itself. Even the math is completely different. They're literally speaking 2 different languages.
And look, this isn't just some abstract debate for scientists. This wall is actively preventing us from understanding the most extreme places in the entire cosmos, the heart of a black hole, and the very first moment of the Big Bang. These are the places where the super big meets the super small. And to understand them, our two best theories have to work together. And right now, they just can't.
So this deadlock has led many physicists to believe we're right on the edge of something huge. That maybe the so-called flaw in quantum mechanics isn't that it's wrong, but that it's just one piece of a much, much deeper puzzle.
What they're really talking about is something called a paradigm shift. It sounds fancy, but all it means is a moment when science doesn't just add a new fact, but completely throws out its old rulebook and rewrites its most fundamental ideas about how reality even works.
And we've seen these massive shifts happen before. Copernicus told us the Earth isn't the center of everything. Then Newton came along and realized the force pulling an apple from a tree is the exact same force holding the moon in orbit. Then Einstein blew everyone's minds by showing that space and time aren't separate things at all. Each one was a radical break from the past, and it feels like physics is holding its breath, waiting for the next one.
But building this new theory? Oh man, it's an enormous challenge. It's like designing this incredibly complex machine. It has to keep all the parts of quantum mechanics and general relativity that we know work, but somehow make them fit together in a totally new way. It has to explain everything the old theories do, make new predictions we can actually go out and test, and, this is key, it has to simplify back down to the old theories when you're in the right conditions. The bar is incredibly high.
And that brings us right back to Gerard Hooft. See, his frustration isn't that quantum mechanics is bad science. His point is that the field has become so successful, so revered, that it's started to treat its own ideas as sacred, and that makes it really hard for truly revolutionary new ideas to break through. He believes that to finally tear down that wall, we have to stop thinking inside the very box that a century of success has built for us. So, is our most successful theory wrong? Maybe incomplete is a better word. Maybe all those weird, illogical ideas that troubled Einstein and Schrödinger so much, maybe they aren't flaws at all. Maybe they're clues. Clues pointing us toward a deeper, more elegant, more beautiful theory we haven't even discovered yet. And that leaves us with one final incredible thought. Are we, right now, living at the dawn of the next great scientific revolution?